Hello and welcome to the research pitch, the presentation and research pitch for my honours project, multimodal topic modelling and its e-commerce applications for Instagram. My name is Jared Mager. I'm studying a Bachelor of Computer Science honours at the University of Technology, Sydney. Just to start off, a bit of contents for the presentation. We're going to start with the research background. Then we're going to look at topic modeling, LDA versus NMF. We'll have a problem statement, the solution that I proposed, the implementation of that solution, the evaluation metrics, and then we'll look at the results visualization and a conclusion. Through a fusion of data collection models like text mining and image processing, multimodal topic modeling can expose the connection and improve the analysis of e-commerce in social media. Current abstractive text summarization models fall victim to unfortunate problems like hallucinations, decreased efficiency, low quality, and even factuality degradation, meaning that some summaries were found to include facts that were absent in the original document. Models like the Fact Pegasus model proposed a three-pronged approach, which was a corrector to remove these hallucinations, a contractor that could tell the difference between a factual and a non-factual summary items, and a connector that would round out the differences between fine-tuning and pre-training. In another report that looked at the fine-tuning for opinion summarization by Dreyer in 2022, it was found that pre-training adapters can be applied to short and disconnected documents, resulting in better organized summary content, improving overall coherence, and reporting fewer redundancies. Some results are lackluster. For example, models that apply input truncation return a decrease in performance based on the fact that relevant content is completely left out of the summary, which in turn can cause destruction for semantic text analysis. Image processing combines complex tasks such as multi-label recognition, object detection, and segmentation, and can be split up into two overarching categories, parametric and non-parametric. As a result of the complex nature of images and their tendency to have relation to multiple topics, dataset pre-processing has to be successfully implemented prior to any image feature extraction. During the initial research of this project, it was thought that latent derelict allocation, or LDA, which is the diagram on the left, would be the most useful topic modeling method. However, in some multimodal cases, its deficiencies were highlighted. So LDA is a generative probabilistic model that assumes that a document is a mix of topics and a topic is a mix of words. This can handle the uncertainty of topic assignment, but it can be harder to interpret due to the randomness involved. It also requires non-negative input, and all of the elements within the input have to be integers representing word counts. Non-negative matrix factorization, on the other hand, was the other option and can be diagrammed on the right. Factorizes a non-negative matrix into two low-ranked non-negative matrices, assuming there is no underlying probabilistic model, and learns parts-based, spares, and more interpretable representations. Its deterministic result makes it consistent across runs, which is extremely relevant to my project because it took multiple trials for my proposed solution to be finalized. Non-negative matrix factorization provides several advantages over LDA when dealing with dense feature spaces such as those found in the Instagram dataset and exposed by the image feature extraction. In many cases, NMF is able to provide results that are more easily interpretable. Specifically for images, NMF enforces non-negativity constraints, which can be useful for image data where the identification of parts or components is valuable. Due to NMF's algebraic foundation, it can be adapted to multimodal data by factorizing the combined data representations. But now we move on to the problem. Existing multimodal topic modeling frameworks are not specifically calibrated for social media sites like Instagram, rendering research about e-commerce for these platforms almost impossible. So my solution was to collect an Instagram-specific dataset through the use of a custom web scraper implementation, compare existing topic modeling methods, and use this knowledge to implement my own multimodal topic modeling framework that's specific for Instagram datasets. I'd be running the resultant topic modeling script to complete the topic modeling of the Instagram dataset and output visualizations for evaluation and analysis. In turn, developing evaluation metrics for the proposed framework and discussing ways in which these visualizations, in conjunction with the proposed framework, can be embedded in the future of social media e-commerce. It was the hope that these visualizations could be used for more effective targeted advertisements and the prediction of user shopping interest, boosting sales, goodwill, and market share. It also aims to increase the conversion rate between social media targeted advertisements and product service purchases. The proposed framework will be compared against an existing multimodal topic modeling / image clustering visualization tool that I found by the name of Concept Modeling, which is a statistical model package constructed by Grutendorst in 2021 that introduces topic modeling to text and images simultaneously and produces multimodal representations of these concepts. Implementing multiple topic modeling techniques on the same dataset with similar parameters will allow for accurate semantic analysis of our framework and assist in suggesting ways it could be improved. Now I'll move on to my implementation. So we started with data preparation. The dataset comprised of both text and images and underwent pre-processing to format it appropriately for training. Even though this was completed before the construction of the topic modeling framework, it was decided that it would be beneficial to include additional pre-processing function in the IGN, the Instagram-specific non-negative matrix factorization script, which is what I'm calling my proposed solution. Again, text data was tokenized and cleaned, stripping any low information stop words, while the images were normalized and resized to conform with the input requirements. The feature extraction, in reference to the technical side of the feature extraction, the pre-processed tokens were converted to a term frequency inverse document frequency matrix. This provided a numerical representation for the caption data. Simultaneously, image features were extracted from the resized images using a pre-trained convolutional neural network, transforming the visuals into an informative set of features. The NMF model was initialized with the parameters, with preset parameters, so eight images for each topic and 10 top words from that topic. During model training, the NMF algorithm iteratively updates its components, meaning it learns to reconstruct the original data matrix from underlying topics. The aim of this step was to minimize the errors found in reconstruction, and these errors can be quantified as the difference between the original matrix and its NMF-based approximation. The training involved multiple iterations until the model's reconstruction error converged below a threshold that was predetermined by the implementation tool. Upon the conversions for the data, the model's performance was able to be assessed to produce accurate visualizations of the topic, ensuring the identified topics were interpretable. Now we move on to the evaluation metrics. Due to the nature of IGNMF topic modeling framework being multimodal, computational evaluation was considered to not be a viable evaluation source, and adapting these metrics is out of scope of the report. Hence, human evaluation based on cross-modal coherence and topic interpretability will be the main evaluation metric for this dataset. Cross-modal coherence consists of presenting human annotators with topic visualizations produced by the script and asking them to rate the similarities between the top words and the images displayed on a scale of 1 to 10, with a higher number corresponding to higher coherence. Topic interpretability will be evaluated similarly, asking a group of annotators to describe or label the topic as high, medium, or low, with which the topic can be labeled, mapping to its quality. For the results of this project, a group of 4 annotators was selected to evaluate the Instagram-specific non-negative matrix factorization framework visualizations based on the human evaluation metrics listed above. Now we look at a results example, and the demonstration of how the algorithm works can be found in the folder, in the zip file that I've also attached. The Instagram-specific non-negative matrix factorization topic modeling framework shows significantly more success in clustering more abstract topics, as you can see in this figure, medium to high topic interpretability across all annotators, as you can see here, same visualization, which can be attributed to the similar nature of the image clusters in addition to the top words provided in the visualization. All the images in the cluster feature full body angles of males showcasing their outfit choices, so the image cluster was pretty accurate, and the top words such as classy fashion, daytime, and canon reaffirm the cross-modal coherence and directly relate to the cluster. Some issues that we find with the dataset, however, is the textual nature of hashtags, which can be seen in some of these top words being a mesh of multiple words, as well as some that aren't words or that aren't in English. Due to the number of words processed for the 500 images in the dataset, there was too many words to display only displaying only 8 the top 10 topic words doesn't cover every single word in the dataset, meaning some words get left out, and it seems like it's just the alphabetically first 8 words that are selected by the model. In addition, there's also some images in different topics that weren't relevant to the topic, which can be seen in my other results visualizations. In conclusion, the development of an Instagram-specific multimodal topic modeling framework provided accurate topic visualizations in addition to a solid foundation for further e-commerce analysis. Currently, the framework still requires human intervention to successfully link the topic visualizations to potential shopping interests of users. However, through social network integration, this process could become autonomous. Whilst the cross-modal coherence of the proposed solution was evaluated to be somewhat low, overall topic interpretability was higher as a result of the image clustering algorithms implemented. The proposed topic modeling framework provides a synthesized solution to data scraping, dataset pre-processing, and topic modeling that can be applied to other short text multimodal sources. However, based on the semantic limitations of the results collected, some further work can be implemented to processing caption data and filtering out posts that are not applicable to the dataset in order to improve results. Importantly, the proposed IGNMF multimodal topic modeling framework successfully provides advertisers and other e-commerce stakeholders with topic visualizations that can be used to push product advertisements and ensure higher purchase conversion rate. Thank you.